I'm talking about a commercial building airtightness database that we've been collecting in the U.S. for a number of years. I'll say probably close to about 20, though our first commercial building airtightness measurement was in the mid-'80s, in the first building we tested. And right now, most of this work of managing the database is being done by Steve Emmerich, who couldn't make it today, but I could, so I'm making the presentation instead of Steve. And so I'm basically going to talk about this database. I'm not going to talk about, unless some questions come up, about some of the various issues that have been pretty well addressed already in terms of structure of the database and management and so on, because I don't want to repeat all the other good points. I'm really just going to talk about this, our efforts here. So, there we go. You know, I think a lot of this should be clear to the people participating today that airtightness of buildings is important in terms of how it affects energy use in buildings because of the increased heating and cooling loads, the impacts on indoor air quality because the air that comes in through these leaks is not filtered, it's not controlled. And then finally, there are issues of material degradation related to moisture, but not exclusively to, you know, some outdoor contaminants can harm building materials if they're not brought in intentionally through a system where they can be filtered out. Another reason we care about airtightness rates is because we want to do some analysis of the impacts on indoor air quality and energy. And finally, just a general point, which is that infiltration is a really bad way to ventilate a building because it can't be controlled in terms of the rate and the distribution. Even leaky buildings can be underventilated during very mild weather, which not all people realize, though I'm sure most of you do. So our first publication on this came out in the late years of the last century, where a lot of people, primarily in the indoor air quality field, were talking about tight building syndrome and hermetically sealed office buildings. And we, based on the small number of measurements we had done, we realized that wasn't the case, that most buildings were quite leaky. So we first assembled a database and published some of the results in the late 90s. Until very recently in the U.S., there were no commercial building airtightness requirements, no testing requirements, no air barrier requirements, no requirements for specifying anything in particular in the design that would make the tight building. Nobody designed the building to be leaky, but in reality, you know, unless you design it to be tight and take some care, there's a good chance it's going to be leaky. So some of the historical data that we collected over the years, you know, shows for 228 commercial buildings in the U.S., the mean air tightness in units of meters cubed per hour per meter squared of envelope area at 75 pascals, which immediately brings up an issue that's been raised earlier about what's the metric to use. And we're all able to convert them between different metrics, but it can be an unnecessary pain in the neck, I think is the term, you know, to do that conversion every time. And just for reference, I listed some equivalent leakiness values for some homes. And if you take a home of kind of a typical U.S. home size and convert the air changes an hour at 50 Pascal to these units of meters cubed per hour per meter squared at 75, you can see on a per square meter basis, the U.S. commercial buildings were pretty, you know, just as leaky as a U.S. home, which is really nothing, which is quite leaky. So on a square meter basis, U.S. homes and U.S. commercial buildings historically have been pretty leaky compared to some of the tighter buildings that have been and are being built in other places in the world. But things are starting to change. I apologize for the garbled text on, or garbled font on the vertical axis. But one common belief, not based on fact, was that newer buildings were tighter in the U.S. So we plotted the data we collected, the airtightness data versus year of construction, and saw no trend at all. Some old buildings are tight, some old buildings are leaky, and that trend has continued. But there was no data, up until early part of this century to support any conclusion about new buildings being tighter. Now, they could be tighter, but there's no data to support that conclusion. We also looked at the energy impacts of commercial building leakage. I won't go into this in detail, but we looked at 3 types of buildings: retail, office, and apartment. And we looked at 5 climates. For those of you not too familiar with the U.S. climates, the 2 on the left, Bismarck and Minneapolis, have some very harsh winters. St. Louis has hot summers and cold winters, and then both Phoenix and Miami are warmer climates. And we showed through this analysis, kind of looking at typical airtightness and improved airtightness, that the energy savings for heating and cooling were potentially quite significant. We always believed this, but the analysis supported our preconceived notions. So more recently, some organizations, such as ASHRAE, some federal agencies, and some state governments have started to add airtightness regulations. And either it's a material requirement, meaning you have to have an air barrier in the design with the material with a certain level of tightness as listed here. And here we see liters per second per meter squared. So I just wanted to, show you that I also could use different units and make things confusing. But if you multiply this by 3.6, you'll get the other units in the earlier plots. So some requirements are in terms of the air barrier material. Some requirements are in terms of the assembly, taking that material and putting together with its various components, which tend to be leakier than the material itself. And then finally, there are some whole building testing requirements. So ASHRAE standard 90.1, which is the energy efficiency standard, has a air barrier requirement, which was added recently within the last couple of years. ASHRAE 189.1, which is the green building, kind of high-performance green building standard, has a whole building testing requirement, testing value as well, but is not required. It's an option. And then IECC and IGCC are 2 different building codes. The U.S. Army Corps of Engineers is a government agency that builds a lot of buildings for the military. They have added a whole building testing requirement for all their buildings, which is really a big step forward and has had quite an impact. GSA is the General Services Administration, is a government agency that has a requirement, but I don't know how well it's enforced. A number of states have some requirements, and 1 city is listed here. So we're starting to see in the U.S. some actual airtightness requirements in commercial buildings, finally, but they are inconsistent, and there's room for improvement both in their consistency and their enforcement and their implementation. This plot shows in the red dots the kind of historical database of commercial building leakage that we've assembled. And the blue dots in the lower left of the plot are the more recent data, test data from the Army Corps of Engineers, which shows how much tighter they are. They're all, and the units displayed here, about 5 meters cubed per meter squared per hour or less, while the other buildings, a small fraction are that tight, and many of them are much, much leakier. So there's this new data coming out of these various programs, which is justifying these tighter tightness standards and demonstrating what works. And there's a lot to be learned from these, and I think we'll hopefully be doing even better in the future. A couple of thoughts on what we're up to with this database and the related issues. We are acquiring more data on the tighter buildings, so we're going to be able to, through this database, really show, the beneficial impacts of these programs and hopefully get a better sense of what works and what doesn't. The ASHRAE standard I mentioned earlier, 189, is considering a proposal to require whole building airtightness testing. This is the high performance green building standard, and that proposal will go off for public review very shortly. And Standard 90 is considering a new approach to considering tightness under their performance path. And finally, these are all new building standards and new building programs, but there's a lot of existing commercial buildings that are quite leaky and a need to deal, with the retrofit. It can be hard to retrofit residential buildings, and it can be much harder to retrofit a commercial building. And hopefully some approaches and technologies and ideas can be generated to deal with the large number of existing buildings which are quite leaky. So that's the end of my presentation, and I'll turn it back to our host.
Okay, thank you very much, Andy, for your presentation. Very clear. And